if the polynomial had roots 5i and x equals 5/2, then we can work backwards to find out what were the factors that created these solutions. Multiply those factors and we've got the polynomial. There's only one thing that's missing, and that is that if 5i is a root, then the complex conjugate, negative 5i, has to be a root as well. So that means from this one, x minus 5i is a factor of the original polynomial, x plus 5i, and then from this one I should multiply by 2 so that it's 2x equals 5, and then move the 5 over. So 2x minus 5. Now use algebra to multiply these out. It's easiest to multiply these two together first, because there's going to be, for the middle term, a negative 5i times x, and for these two it's going to be positive 5 times x, so they cancel. So we're left with the first term times the first term, which is x squared, and the last term times the last term, which is negative 25i squared. And then I squared is a negative 1, so this actually becomes a positive 25. So we've got x squared plus 25 gets multiplied with a 2x minus 5. And then distribute, so we've got x squared times 2x, so 2x to the third. And then an x squared times negative 5. There's a 25 times 2x for 50x. And the last one times the last one, 5/4 would be $1.25, so that's 125. And then call that the polynomial. And if you'd like to check the answer, you can take one of the results, like one of the answers, 5/2, and store that. So down here, store that as x, and then our polynomial is 2x raised to the third minus 5x squared plus 50x minus 125, and the answer should be 0. Nicely done. You can do it with the complex numbers as well. Down here at the bottom of the calculator is the I, so just put 5i and store that as x. And you don't have to retype this, because if you hit second enter, it'll give you the last thing you did. And if you hit second enter again, it'll give you the previous thing. It remembers the last 10 things that you've done. So now it's going to take that 5i and substitute it in, and we should get the answer 0. Perfect.